Hello everyone, welcome to the discussions of the past year questions. This video we shall discuss about further statistics, October-November 2023, paper 42. Let's take a look at the question number 1. A factory produces small bottles of natural spring water. Two different machines X and Y are used to fill empty bottles with water. A quality control engineer checks the volumes of water in the bottles filled by each of the machines. He chooses a random sample of 60 bottles filled by machine X and a random sample of 75 bottles filled by machine Y. The volumes of water X and Y respectively in millimeters are summarized as follows. Bar X and bar Y are the sample means of the volume of water in the bottle filled by machine X and Y respectively. Find a 95% confidence interval of the difference between the mean volume of water in bottle filled by machine X and the mean volume of water in bottles filled by machine Y. So for these questions, we are looking for confidence interval. But before that, we need to get ready some of the data first. We need to find the bar X. So the bar X will be 6345 divided by 60. And we need to find the bar Y. Bar Y is a 7614 divided by 75. Press the calculator. You will get 105.75. This one you will get 101.52. Then we need to find the unbiased estimations of the population variance of X. So this one will be 1 over 64, 1 over 59, sorry. Multiplying by 243.8. So this one you press the calculator, you get 4.1322. Same thing goes for the unbiased estimations of the population variance of machine Y. You will have 1 over 74 multiplied by 384.9 and you will get 5.2014. Okay, so we need to have these two things ready first. Then we need to combine these two samples become one. So we have a combined variance. We just write this one as a combined variance. S squared. It will be the Sx squared over the Nx plus the Sy squared over the Ny. So it will be 4.1322 divided by the 60 plus the 5.2014 divided by 75. Press a calculator, you will get 0.13822. Okay, so now we are ready to find the confidence interval. Your critical value, two-tail, so you will get 0.975 from the formula booklet MF19. 975, you will get it as a 1.96. So your 95% of the CI. Okay, for the difference between the mean of the volume X and Y. So this one we just straight away write like this. Bar X minus a bar Y plus minus of Z 0.975 square root of the S square over N. Oh, sorry, no divide N, because we already divide N here. Right? We already divide N here, so there's no need to divide N. So just square root of S square will do. So this one is 105.75 minus 101.52 plus minus of 1.960 square root of 0.13822. So press the calculator, simplify it, your answer will be 3.50 in 3 significant figure and 4.96 inclusive. So this will be the answer for the question number 1. Just like that, done. Moving on, we have question number 2. For question number 2, you have the number of breakdown on a particular sections of roads in recorded each day over a period of 90 days. It is suggested that the number of breakdowns follows a Poisson distributions with a mean of 3.5. The data is summarized in the table together with some of the expected frequency resulting from the suggested Poisson distribution. So they want us to complete the table here. So what you need to do now is to find this value. I call this one E1. I call this one E3. I call this one E6. Expected value. Okay. So E3 is equals to, you have 90 days. Okay. I think first of all, we should find the Poisson distribution. X is the Poisson distributions of mean 3.5. Then the E3 is actually equals to the 90 days multiplied by the Px equal to 3. So it will be 90 multiplied by e to the power of negative 3.5. 3.5 power 3 divided by 3 factorial. Press the calculator, you will get the answer as 19.421. So you can see that all the value here are in 3 decimal places. So my answer also will follow 3 decimal places. So we just follow this. Then move on. We want to find E6. E6 will be 90 multiplied by Px equal to 6. That will be 90 multiplied e to the power of negative 3.5. 3.5 power 6 over 6 factorial. Press the calculator, you will get 6.939. Done. That will be the answer for the part A. Now moving on, we want to carry out a goodness of fit test at 10% significant level to determine whether or not this is a good fit or not. So for this question, quite straightforward. The null hypothesis and the alternative hypothesis is that we just mentioned that this is a good fit. To the data. Okay. Then this is not a good fit. Okay. Then we build the table. We need to build the table again because this one less than 5. This one less than 5. This one less than 5. So we need to combine them together. So over here, I will show how to combine them. Okay, so I have to redraw again the table. We have the number of breakdown. This one will be combined together, become less than or equal to 1. Then 2, 3, 4, 5, 6, and greater than 7. Okay, so this one is observed frequency. This one is expected frequency. So observed frequency combined together. 17, 21, 16, 9, and then 9. So we combine them together. So this one you get 12.23, 16.646, 19.44, 16.993, 11.895, then 6.939. And the last one will be 5.876. As long as it's greater than 5, then you can stop already. So degree of freedom. You have 1, 2, 3, 4, 5, 6, 7 of them. Minus 1. So you get 6. The reason here is because of the sum of the observed frequency is equal the sum of the expected frequency. So for this reason, we minus 1, then you get 6. Now the critical value, your chi square of 90% and the degree of freedom 6. Just use your formula table. 90%, degree of freedom 6, so you get 10.64. So it's just 10.64. Now we can go for the test statistics. It's the sum of the OI minus the EI square divided by EI. So this one, it will be just straight away, each and every one of them, I just straight away implement into this formula. That means I will not going to write like this. I will skip this process. Okay, this process, I will skip it. I will just direct press the calculator from the result here one by one. So over here, my result will be 4.274, 0.799, 0.302, 0.945, 1.417, 0.612, 1.663, 661. So you all add up together, you will get 10.0 into 3 significant figure. Okay, so if you rounded it up to 3 significant figure, you will get 10.0. So this is your test statistics. Now you compare your test statistics. Compare with the critical value. So obviously the critical value is larger than the test statistics. Okay, so test statistics less than the critical value. That means you're supposed to accept H now. Conclusion. So at the beginning, the claim was they want to know is a good fit or not. So it's that means it's a good fit lah. There is sufficient evidence to support that X with the Poisson distributions of mean 3.5 is a good fit. To the data. Okay, done. That will be the answer for the question number 2. Now we move on to the question number 3. Okay, now we take a look at number 3. Toby has a bag which contains 6 red marbles and 3 green marbles. He randomly chooses 3 marbles from the bag. Without replacement, the random variable X is the number of red marbles that Toby obtains. Find the probability generating function of X. So over here, we'll build the probability distribution table in order to find the PGF. So since you're selecting 3 marbles, so the random variables will be 0, 1, 2, and 3. Okay, that is what the table is supposed to look like. So you need to show 3 marks only. So actually, we need anyhow we need to show how to get the answer for at least one of the probability here. So I'll show Px equal to 0. Px equal to 0 supposed to be you have, that means no green marbles. So 6 of the red marbles you get all green, all red. Then 3 green you get none. Then total you have 9 C 3. Just like that. And then you press the calculator. Px equal to 0. Oh, sorry. This one is looking for red marbles. So that means this one's supposed to be 6C0 and 3C3. My apologies. This one's supposed to be 6C0 and 3C3. So we need to read the question carefully. This one is 1 over 84. So we have 1 over 84. The rest of them, actually, you can just calculate from the calculator directly and then fill up yourself. So over here, I will still show for all of them. 6C1 multiplied by 3C2 divided by 9C3. So over here, I press the calculator, I get 18 over 84. Okay, I don't plan to simplify it. I want to remain my denominator all same, 64. So I don't plan to simplify it. So for Px equal to 2, it will be 6C2, 3C1 divided by 9C3. So this one again, you press the calculator, you get 20 over 84. So again, I don't plan to simplify it. I just write 0 over 20 over 84. Then this one is 18 over 84. The last one supposed to be 1 minus the 3 of them. Right? The last one supposed to be the 1 minus the 3 of them. Then you're able to get the last one. But over here, we want to double check. So if you want to double check, you can continue to find it the same way, like just now. So I'm taking the Px equal to 3. That will be 6C3 multiplied by 3C0 divided by the 9C3. Press the calculator and you get the answer as... Oh, sorry, I make a mistake. This is 45. This is 20. My apologies. This one is a 45. This one is 20. So the total here must be a 1. If you didn't manage to get 1, that means you have made some mistake in between. Okay, so this is the answer for the question part A. Then after that, part B, Ling also has a bag which contains 6 marbles, 6 red marbles, 3 green marbles. He randomly chooses 2 marbles from his bag without replacement. The random variable y is the number of red marbles that Ling obtains, it is given that the PGF for the y is this. Okay, I haven't find the PGF yet. So I need to find the PGF. So the PGF here will be 1 over 84, d power 0, plus 18 of 84, d power 1, and 45 over 84, d square, plus the 20 over 84, t cubed. That is supposed to be the answer. Then now they give you the PGF for the y as 1 over 12, 1 plus 60, plus the 5d squared. So now they say that the z is the total of x plus y. Okay, so by find the PGF for the z, expressing your answer as a polynomial in terms of, so the gzp is equal to the gx plus yd. It will be equal to the gxt multiplied by the gyd. So it will be 1 over 84 of 1 plus 18 t plus the 45 t squared plus the 20 t cubed. Then this one is 1 over 12 of 1 plus 60 plus the 5t squared. So what you need to do is just to all the constant join together. So the constant, this constant and this constant, if you multiply them together, you will get it as a 1 over 1008. So if you expand it, so it's kind of long to expand all over here. So I don't plan to expand them in detail for you. You can try to expand it yourself. Try to practice how to expand them yourself. I just give you the answer that I have expanded earlier. So this is the result for my expansion. 158t square, 3x0t cube, 345t power 4, and 100t power 5. Okay, so this will be the answer for the B. And now we move on to the question C. They want you to use this BGF of Z to find the variance Z. So to find the variance Z, we need to differentiate for the first time and differentiate it for the second time. So based on the result that we have, if you differentiate it, you get 1 over 1008, 24 plus 3160. The 1 after you differentiate, it will be disappeared, becomes 0. So this one is 3160 plus the 1140t square, 13x0t cube, 500t power 4. And if you differentiate for one more time, 316 plus the 2x0t, 22x0, something missing. 22x0. 4140 t square and 2000 t cube. Okay. Now we just need to substitute the value inside. Our G prime 1, G double prime 1. So if you press a calculator, sum everything up, just use your calculator only. Make the t become a 1. This is what you get. 10 over 3. This one you will get 8736 divided by 1003. And you will get the answer of 26 over 3. Okay, now we are ready to find the variance. The variance for the Z is G double prime plus the G prime okay, this is a 1. So we just use this formula. So you get 26 over 3 plus 10 over 3 minus the 26 over 3 square. Press the calculator directly. You can get the answer 8 over 9. Okay, so this will be the answer for the part C. Okay, moving on. We have question number 4. Okay. Okay, now we take a look at question number 4. The diagram shows a continuous random variable x with a probability density function f given by following here. A, B, and C are constant. The question mentioned that the upper quartile of x is equal to 4. So that means this one will give you 25% or 0.25 or 1 over 4. Okay. Or you can say another way is that the portion over here, this portion will give you 0.75 or 75%. Okay. So I think I will use this part. It's easier because you can see obviously this one is a rectangle. So to find the area, it will be easier to find by using the rectangle formula. Okay. So the question mentioned is a C. That means the height over here is a C. Then this one, the length over here is 2. So 2C will equals to the 25%. Okay. So we need to show the C is a 1 over 8. And then after that, we want to find the values of A and B. So what you need to do now is just need to write that the P for to 6 is a 1 over 4. Then you are having the C multiplied by 2 is equal to 1 over 4. Then your C is a 1 over 8. Done. So that is the answer for the C shown. Now we want to find the value of A and B. So we just make use of this point. This point, it will be 4, and the height is a C. C is 1 over 8. So we are having F4 is equal to 1 over 8. So F4, just need to substitute 4 inside here. You will get 1 over 128 of 16A minus the 64 B equals to 1 over 8. Factorize the 16 out. Then you can get this as the 1 over 8 of A minus the 4B equal to 1 over 8. Cancel it. You get A minus the 4B is equal to 1. Okay, that is my first equations. For the second equations, like what we mentioned just now, this part is 1 over 4. That means this part will be 3 over 4. So that means the probability from 0 to 4, it will give you 3 over 4. That means you can integrate 1 over 128 4ax minus a bx cubed dx will give you 3 over 4. So integrate this will give you 2ax squared minus the bx power 4 over 4 from 0 to 4. It will give you 128 multiplied by 3 over 4. I bring the 1 over 28, 1 over 128 go to the right hand side. So this one you will get 32A minus the 64B minus the 0 is equal to 96. Divide everyone by 32. That is your second equation. I think I continue over here. Take the equation number 1. Take the equation number 2 minus the equation number 1. You will get 2b equals to the 9 over 4. Hey, no, wait. Two b minus 2b is equals to 2. Then your b is equal to 1. So from the equation 1, you get a is equal to 1 plus 4b. Then your a is a 5. So therefore, your a is a 5 and your b is a 1. So that is the answer for the part A. Moving on, with the value of a and b that we found, now we want to find the median of x. So to find the median of x means that from the probability from 0 until m, which is the median, it will give you half. So obviously, the median must be somewhere here, because you want to have 50%, you want to have 50%. So the median must be half. So that means you just need to integrate from 0 to m, 1 over 128 of 4ax. Just now the a was 5, so it's 20x minus the bs cubed, so it's s cubed, half. So you get 10x squared minus x to the power of 4 over 4. 0 to m is equal to 64. So you have 10m squared minus 1 over 4m power 4 is equal to 64. Multiply everyone by 4. You will get m power 4 minus a 40 m square plus the 256 equal to 0. So we can use the calculator to help us to find the m. Or if you can, you factorize it. Okay, so this will be the factorization. And the m square equal to 32, sorry, 32. The m square equals to 8. So your m equal to the plus minus of, we know the m is all positive now, okay? But over here, this value is too big. Okay? So over here, this you have to ignore. Okay? Because your m is between 0 and 4. Okay? Because of this reason, you ignore. So this one, you're supposed to get positive, negative, sub 8, but m is positive. Therefore, you have 2 sub 2. That is your m. In one exact value. Okay? So that will be the answer for the part B. Then moving on, we want to find the E of the sub x. So E of the sub x is, this one will be a bit troublesome. You need to integrate from 0 to 6 sub x of the function. We need to split them, become 2, 0 to 4. Sub x of the 1 over 128 of 20x minus the x cubed plus the 4 to 6 of c. C is a 1 over 8. So I just need to expand them. I will make it become, sub x make it become power of a half. But over here, I think I will bring the 1 over 128 out first. I don't want to involve so many of fractions. So this one, it will be integrating the 0 to 4. This will be 20 of x power 3 over 2 minus the x power of 7 over 2 dx plus the 1 over 8 integrate 4 to 6 x power half dx. Then just need to integrate carefully. Nothing tricky, just have to be careful only. So you have 8x power of 5 over 2 minus the 2 over 9 x power of 9 over 2 from 0 to 4 plus of this x 2 over 3 x power 3 over 2 from 4 to 6. So we are having 8 4 power 5 over 2 minus a 2 over 9 of 4 power 9 over 2 minus a 0 plus the 1 over 12 of 6 power 3 over 2 minus a 4 power 3 over 2. This will not give you that nice value. So we can, the question didn't mention, the question 1 decimal places, 2 decimal places. So we can straight away press the calculator from here and you will get the answer as 1.67. That will be the answer for the part C. Okay, so now done for this question and move on. We have question number 5. Okay, now we take a look at question number 5. A company is deciding which of two machine X and Y can make a certain type of electrical component more quickly. The times taken in minutes to make one component of this type are recorded for a random sample of 8 components by the machine X and a random sample of 9 components made by machine Y. These times are as follows. Okay, so these are the data given. The manager claims that on average, the time taken by machine X to make one component is less than the time taken by the machine Y. Carry out a Wilcoxon rank sum test at 5% significant level to test whether the manager's claim is supported by the data. So over here, we just, since it's Wilcoxon, we are going to consider this as a median. We want to consider the median. So the population median of the X is equal to the Y versus the population median. They say that the median of X is less than the median of Y, according to the manager's claim. Okay, so this is what we have. Then to save time, I draw the table over here like this. Then we need to put the ranking over here, the ranking from in ascending order. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. Okay, so if you do it this way and you sum it up, you get 55 and you get 98. So the test statistics W will be equal to the minimum between the WX and the WY. So from here, you can see that the minimum is 55. That is our test statistics. Both of the n is less than 10, so it's considered as a small sample. We no need to convert it into normal distribution. So we can just straight away find the critical value, or we call it tabular value. So over here, I call it critical value. So critical value, just look from the formula booklet. So we are going for the rank sum test. Okay, so rank sum test, your M, okay, M must be the one that is smaller, N is bigger. So these questions, the M is 8, the N is a 9, okay? And your significant level is 5%. So it's 1 tail. So you have 95, 5%. So 5%, 1 tail. So 8 and 9. 8 and then 9. So it's over here because it's 1 tail, 5%, sorry. So 54, okay? So your critical value is 54. Just write like this will do. Then your test statistics and your critical value, if you compare, your test statistics is greater than the critical value. So this result, because it's Wilcoxon, the result will be opposite. If the test statistics is greater than the critical value, you just accept H now. So conclusion, there is insufficient evidence to support the manager's claim. Okay, so this will be the answer for the part A. Now, we move on to the part B. Assuming that the time taken to produce the component by 2 machines are normally distributed. So you can see that when we assume that it is normally distributed, we're expecting to have the t-test. Okay. Carry out a t-test at 5% significant level to test whether the manager's claim is supported by the data. So since we want to do t-test, we need to find the sum of the x and the sum of the y. That means I need to total all the value here, add all up. After that, you need to square all of them. and you add all up to find the sum of the x squared. Same thing happened for the y. So to save time, I have calculated it earlier. So the sum of the x I calculated earlier is 39.7. Then the sum of the y is 49.5. The sum of the x squared, the sum of the y squared. In exam, when you calculate it by yourself, it will take quite some time. So you have to know how to manage your time properly. So this one I have calculated for you earlier, so things can go quite fast over here. So this is what we have for the sum of the x and the sum of the x squared. From this data, we can find the bar x. Bar x is just taking the 39.7 divided by 8. And the bar y is at 49.5 divided by 9. So over here, you will get 4.965. This one, you will get 5.5. Then to find the unbiased estimations of the population variance of x and the unbiased population variance of the unbiased estimations of the population variance of y, formula only 1/7 275.47 minus the 39.7 square over 8. Press the calculator, you will get 0.4025. Same thing happened here, 1/8 of 199.33. Sorry. I used the wrong value. My apologies. Copy the wrong value. This one is a 199.33. This one is a 275.47 minus the 49.5 square over 9. And if you press a calculator, then you will get 0. This one is wrong. This one you will get 0.33125. This one you will get 0.4025. Sorry for the mistake. Now this is small sample, so we need to find the pool variance. SP square. So the pool variance, it will be 7 multiplied by 0.33125 plus the 8 multiplied by 0.4025 divided by 7 plus 8. Press the calculator, you get 0.36 of 925. That is a pool variance. Now, we are ready to do the hypothesis test. The null hypothesis is that the population mean mu x is equal to the mu y. Then versus the population mean of the mu x less than the mu y. Okay, this is a left-hand test. So your critical value, your alpha is 5%. So your test statistics will be, not test statistics, your critical value will be t value, t test. Your degree of freedom is 15. 7 plus 8 is 15. So you get this as a negative 1.753. Negative is because of left tail. Okay. So now, we want to find the test statistics. T is equal to the bar x minus the bar y. Bar x minus the bar y. Bar y is a 5.5. Minus the mean x minus the mean y. Since they are equal, so the mean x minus the mean y will be a 0. So over here, divided by the square root of your pool variance. Your pool variance just now is 0.36925. Multiply by 1 over nx and 1 over ny. 1 over 8 plus 1 over 9. Press the calculator, you get it as negative 1.820. Okay, that is your test statistics. Take the t modulus and take the critical value, you modulus it. Compare, you can see that your test statistics is actually greater than the critical value. So you need to reject H now. Conclusion. There is sufficient evidence to support the manager's claim. Okay, so that is the answer for the part B. So you can see that the part A, we accept H norm, but the part B, we reject H norm. So you can see that we have two different conclusions over here. That's why the question is asking for the part C. In general, would you expect the conclusion from the test in part A and part B to be the same? So part A and part B, we are having different conclusion. So the question is asking, do you expecting them to have the same answer, or you actually expecting them to have a different answer? So over here, you can see that actually the nature of the question is different. Because for part A, if you are using Wilcoxon, we are talking about median. If you are using t-test, we are talking about the mean. So the nature of the question is already different. Of course, we do not expect the answer to be the same. Okay, so and provided when you do t-test, whenever you do t-test, there's assumption that this is normally distributed. But for Wilcoxon, they never mention it's normally distributed. Okay, so Wilcoxon, they never mention it's normally distributed, and it's two different kind of thing, two different kind of situations. So we cannot expect the answer to be the same. So this one, I just follow the suggestion from the suggested answer from the mark scheme. It just mentioned that the t-test is assuming a normal distribution. Oh, not enough, please. And with equal variance. This may not be true. Okay, because we assume only. The question is, the point is we are assuming. So what if our assumption is wrong? So it may not able to give us the correct answer. Okay, so no reason to expect results to be the same. Be the same. Okay, so because you are making assumption over here, so you cannot expect that the answer is supposed to be the same. Okay, so this is the suggested answer given in the mark scheme. Okay, so that's it. That is the answer. That is all for this paper, and I stop the video here.